Good day, guys. We have to look at another problem on regression for mathematics level 4. So this table is showing us the temperatures x and the number of days for x to hash. The background of the story is talking about crocodiles and the temperature during which they hash their eggs. So if the temperature is 28, the crocodiles will hash 87 eggs and so on. So the first part, we need our scatter plot. So let's go to the scatter plot. The scatter plot is just a graph between x and y. And I'll keep saying for level 4 students, this graph page is always designed for you and given to you in the exams. But now that I don't have it, I have to show you how you can design your graph page in case you are unlucky and they don't give you a graph page that has a scale. So how do you put a scale on your graph page? So I start by studying my x values. If you look at your x values, they range from 28 to 32. So that therefore means from 0 to 28, you really don't need those numbers. So if I go to the x-axis, I can put this mark there to show that I'm squeezing my page between 0 to 28. Then I start my scale from 28. It's just a difference of 1 each, so the x values are so easy. So I get 28, 29, I get my 30, 31, and 32. So I hope I managed to make sure that the space between my numbers is approximately the same. On a graph page, that will be done for you and it will be easy for you to see that. Then if I go to the y values, the smallest value is 51, the largest is 87. So again, from 0 to 50, for example, I don't think I need those numbers because what will I be putting between 0 and 50? So I want to start from 50 and my biggest number is 87. So I can make my scale this time to get an interval of 5 each. So I'll get my 55 there, I'll go to 60. 65, 70, 75, the biggest number is 87, will I arrive? 80, I think I made my space to be too big. Let me try to reduce it a bit because I need at least a 90. So I'll just reduce the space a bit. So from 50, I'll get my 55 there, I'll get my 60, get my 65, 70, 75, 80, then 85, and 90. So that way I know that 87 is taken care of. So guys, that's how easy it is to produce a scale for yourself. If you are given a graph page without a scale, you can do that. Then from here, I will start plotting my point. So I've got just 5 points to plot. I need 28 meeting with 87. So this is my 28. It has to meet with 87. 87, where are you? This is 85. I can say this is 86, 87, 88, 89. No, let me increase that a bit. So 86, 87, 88, 89. Yeah, so 86. Is there 87 can be somewhere there. So I'm just trying to estimate since I don't have a graph page. So that is my 87 meeting with 28. Then the next one is 29 and 78. 29 is there, 78, this is 75, 76, 77, 78, 79. So my 78 can be somewhere there. So I get my 78, then 30 meet with 60. I guess that one is easy to trace on my scatter plot. 30 and 60, they meet there. Then the next one, what is it? 31 and 54. There is 31 there, 54 should just be below 55. So that I meet there in the last, but not the least is 32 and 51. So 51 should be above 50. So that is it. It meets with 32. So guys, that is how easy it is to get the scatter plot. And as we know in the exams for maths level 4, you will not suffer like this, because all these points, this graph page will be given to you with the scale, and you will not need to go through the pain that we've gone through. So we can now go to the B part, where we now need to get the regression equation. Our formula for regression is y equal to a plus bx. That formula is formula number 21 on the maths level 4 formula sheet. In this formula, how is my b calculated? One of the formulas is n sum of xy minus sum of x, sum of y, and n sum of x squared minus sum of x, all that squared. So there are two formulas, but that is one of the formulas that I believe it's easier for you to understand. If you understand the other one, it's still okay. So again, as I told you, in the maths level 4, they always give you a table that has been created using this formula or the other one. It's just for you to complete the table, then it will help you to get B. So to create the table, since it's not given to us here, I'll get my x, I'll get my y, then I'll get my xy, then I'll get my x squared. So you see, my x and y, they are coming, they will lead us to the sum for x and sum of y, xy will lead me to this sum, x squared will lead me to that one. So I can now put my numbers. So my x values are 28, 29, 30, 31, and 32. Then we'll need the sum of x. Then we'll need our x bar. I'm just putting the table the same way you will see in the exam as a level 4 student. Then my y values, there's 87, there's 78, there's 60, there's 54, there's 51, then we'll need sum of y, and then we'll also need y bar. So that is it. Then we can now go to the other part. So let's start with sum of x. So we get 28 plus 29 plus 30 plus 31 plus 32. So that gives us 150. So sum of x is 150. So if I divide by 5, I will get x bar, my mean, as 30. So to get x bar, the mean, you take sum of x, you divide by the number of points, which are 1, 2, 3, 4, 5. Then we do the same thing for y. Our sum of y is 87 plus 78 plus 60 plus 54 plus 51. Those are my 5 numbers. They give me 330. You divide by 5, the mean is 66. So that is it. Now we'll go to the next column. We need xy, which means we're multiplying. So I'll take 28 times 87. That gives me 2436. 29 times 78. It gives me 2262. 30 times 60 will be 1800, since 8 times 6 times 3 is 18. Then we get 31, so 31 times 54, it gives me 1674. Then 32 times 51, we'll get 1632. Then I'm going to add up all those numbers, 1632 plus 1674 plus 1800 plus 2262 plus 2436. So I've added 5 numbers. So that gives me 9804. I guess I did it well. Let me say minus 2436 minus 2262 minus 18, just to see if I didn't make a mistake. Then minus 1674 minus 1632. Okay, get me to 0. So that calculation is okay. Then we'll go to x squared. X squared means I take the x values, I square them. So 28 squared gives me 784. 29 squared gives me 841. 30 squared should be 900. 31 square should be 961. 32 square gives me 1024. So now 9804 was sum of xy, that's 9804. Then we get sum of x squared, add up all those numbers, 1024 plus 961 plus 900 plus 841 plus 784. So that gives me 4510. So guys, this is the table that is given to level 4 students in the exams to complete. And as I've told you, students who are good with their calculator can just capture these numbers in their calculator. The manipulated, those answers come out. But the reason why they give you this table is because they want you to understand with little data how these formulas are operated as level 4 students. So that is why we have to go through this thing. So if we now want to calculate b, our n is 5, since your scatter plot has only 5 points, then you multiply by sum of xy, it's down here, 9804, then minus sum of x, which is 150, times sum of y, 330, divided by our n again, which is 5, sum of x squared, I go under x squared, the sum is 4510, minus sum of x, all that square, then I go under x, the sum of x is 150, I square that. So from here, I can now go to my calculator. I'm taking 5 times 9804 minus 150 times 330. That is the numerator. Denominator, I'll take again 5 times 4510 close bracket minus 150 all that square. So this gives me negative 9,6 as my b. So we have succeeded to get our answer for b. So that means in our regression equation we now know what goes for b. Now as a level 4 student we now switch to formula 23, which shows you how to get your a. So your a, that's the formula for a, which means you use your y bar, the mean for the y values from your table is 66, minus again to calculate a. I always advise students that after the bracket, after the negative sign, please put a bracket. Those who fail to do that usually get wrong answers. So my b is negative 9,6, my x bar on my table is 30. So if I calculate this, I will get my answer for a. So I will get my 66 minus, I open my bracket, I put negative 9,6 times 30, bracket close, my a gives me 354. That's what I see, 354. So therefore, if I look at my formula 21 as a level 4 student, my regression equation is 354, then my b is in negative 9,6x. So guys, that is how the level 4 student calculates the regression equation. So we can now go to the C part of the question, which is asking us to use the regression equation to determine the number of days that will take, I think we'll miss the word take there, that will take for x to hash if the temperature is 35. Remember I told you this data, we're given the temperature during which crocodiles hash this number of eggs. So we want to see how many days will it take for the crocodiles to, how many days will it take for the crocodile to hash its eggs if the temperature is 35. So the target here is to check that number of days in your original table. What does it represent? You see, number of days for x to hash is representing our y. So again, we are looking for y when the temperature there is representing our x. So in this case, we've given you your x value to calculate the y. So we want to use this information to do an estimate. So in this case, Again, we are calculating y when x is given to us as 35. So when the temperature is 35 degrees Celsius, how many days will it take for the x to hash? So we've got 354 minus bracket 9.6 times 35. So how many days? It takes us exactly to 18 days according to my calculator. So it tells me that it will take 18 days for the crocodile's eggs to hash if the temperature is at 35 degrees. So guys, that is how it is from what we have seen. So we can now go to the D part of the question, which says what kind of relationship exists between x and y. So again, to know the kind of relationship between x and y, it's easy if you already have a scatter plot. So if your point is scattered in this direction of negative gradient, this is a negative relationship between x and y. If it was in this direction, it's a positive relationship. So we can see clearly on the scatter plot that it's a negative relationship. Another place to see the relationship between x and y is the value of b. If your b is negative, it's indicating that the relationship between x and y is a negative one. So that is why I always keep saying, if you have a scatter plot and you also calculate b, they must be speaking the same language. Speaking the same language in the sense that if the scatter plot says the relationship is a negative one, then b must be a negative figure. If the scatter plot says the relationship between x and y is a positive one, then b will be a positive figure. So my response to D is simply negative relationship. That is what exists between x and y. So we can now go to E and F. They require us to work on the scatter plot. So because E says draw the line of best fit on the scatter plot. So the line of best fit is a line that you draw on your scatter plot and try to link as many of the plotted points as possible in such a way that those points that are not linked on the straight line should be shared approximately equally above the line and below the line. So I'm having only 5 points on the scatter plot. So I will figure out how can I link them with a straight line, but making sure that if points are not linked, they must be shared equally. So if you look at it, it's possible that a straight line can go here, maybe trying to link the 3, but the problem is that those that are not linked will be on the same side, so that will not be the line of best fit. But if I can target this point, that one and that one, then I think I'm getting a better line. So my line of best fit, I'll figure it out that it can be a line that is passing through these 3 points like that. So I hope that line is a straight line. I hope I can manage to get a straight line passing through those 3 points. So I would prefer to call this one a line of best fit, hoping that that line is straight, because it manages to touch 3 of my points, and those 2 points that are not touched are not on the same side of the line. They must be shared equally. If there were 3 points that were not touched, they must be shared 2:1. That is how you know you are seeing a line of the best fit. So that is it. So that is it about the line of best fit. Then the last thing says draw the regression line on the scatter plot. So the regression line that we got was having y equal to 354 minus 9.6x. So you now see that the regression line, the first difference between it and the line of best fit is that the line of best fit has no equation, the regression line has an equation. So with the regression line, we're simply drawing this line. And the best way to draw it is to get 2 points. So if I want a table of values for this line, my table of values, I just need 2 points to draw a straight line. One property of the regression line is that it must pass through x bar, y bar. So that is 1 point, the mean of x and the mean of y. So that is one of the points that I will be putting on my graph. Then to get the other point, I can simply go to my graph, pick any point of my choice, and substitute into the regression equation and see the corresponding y value. That's how simple we do it. So we are dealing with the point 30. Maybe we can go to the graph, we pick 28 and see where will 28 take us. So we saw that 30 is taken up to 66, since that is x bar, y bar. So what about 28? So I will substitute 28 into the equation. So I'm getting 354 minus bracket 28 times 9.6. So that leads me to 85.2, which I can trace it there. So I get 85.2. I can approximate it to 85 since it's not easy for me to get comma 2 in this my graph page. If it was an original graph page, I'll be able to figure out how to get that. So I'll be looking out for 30 and 66. So 66 should be above 65. So if this is 65, I can say this is 66, 67, 68, 69. Now let me increase the bit. So I get 66 there, 67, 68, 66, 67, 68, 69. Yeah, so this can be my 66 there, and 30. So I'm estimating that my point lies here. So I've plotted the first point. Then the other one, I'll be looking for 28, meeting with 85. So 85, it's right there. Or if I can just take it a little bit up just to show that I'm seeing 85.2. So that is how I get my point. So if I can link the two, this one was going a little bit to the right. Yeah. I think it's straight, it's a little bit to the right. So if I can link the 2 points, I see what is my regression line. So that is it. With the regression line, we are expected to draw new point, to plot, new point on the graph. So if I can link the 2 new points I've plotted on my graph, I see my regression line. So it clearly shows to us that the regression line and the line of best fit are not supposed to be the same, except maybe the relationship between x and y is a perfect relationship. So let me draw it with the other marker. So if I link the 2 points there, I'll be getting what is the regression line. So I hope it is a straight line. We expect you to use a ruler to get that. So this is my regression line. So guys, I guess you see the difference between the line of best fit and the regression line, how to draw them on your scatter plot. So I guess we have come to an end, and as before I said, on a scatter plot, if you want to see that a point on a scatter plot is an outlier, it will be very far from the original point. Let's say we've got among this 1, 2, 3, 4, 5 black points, we've got another point plotted far away, that is an outlier. So just to help you see all the information that you can ever get on a scatter plot. So guys, I guess this is the end of our story on regression. Thank you very much.